In this episode, we take the data pipeline idea from the last lesson and zoom in on a part that often decides whether an AI system will be trustworthy over time: training data management. Training data is not just a pile of files you gather once and forget, because real organizations add new data, fix errors, change labels, and retrain models as the world changes. If the training data is not managed with versioning, traceability, and practical controls, the organization can lose the ability to explain what the model learned from, why it behaves the way it does, and what changed when something goes wrong. Beginners sometimes assume the model is the main thing you audit, but in many cases the data management around training is where the most important governance problems hide. When an incident happens, leaders will ask what data was used, who approved it, and whether the organization can prove the system followed policy. This lesson gives you a clear, everyday language way to audit training data management, so you can spot gaps before they turn into failures. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Training data management is the discipline of treating training datasets like important assets with history, ownership, and rules, rather than like temporary materials used for a quick experiment. The reason that matters is that training data influences the model's behavior in deep ways, and the model's behavior influences people, decisions, and risk. If a dataset changes without control, the model can change in ways the organization did not intend, and those changes can affect fairness, privacy, and reliability. When training data is poorly managed, teams cannot reproduce results, cannot compare versions, and cannot explain why performance shifted. In everyday terms, it is like cooking without a recipe and then being asked to recreate the same meal months later for a large event. You might remember some ingredients, but you will not know the exact amounts or the substitutions you made. In AI work, that lack of discipline becomes a governance problem, because accountability depends on being able to show what was used and why. Versioning is the first big concept, and it is simply the idea that every meaningful change to training data should create a new, identifiable version rather than silently overriding what came before. Beginners often associate versioning with software code, but datasets need it just as much, because changing a dataset changes what the model can learn. A version can change when new records are added, when records are removed, when labels are corrected, when fields are transformed, or when filtering rules are updated. The key is that versioning makes change visible and reversible, which is essential for responsible oversight. If a model suddenly starts behaving strangely, you need to know whether it trained on a new dataset version, and you need the ability to compare that version to the prior one. Versioning also supports learning, because you can measure whether a dataset improvement actually improved outcomes. Without versioning, organizations can end up in a fog where nobody can tell what changed, and the only response to problems is guessing. A practical audit view of versioning starts with asking whether dataset versions are uniquely named, and whether the naming scheme is consistent enough that teams can communicate clearly. You are not looking for fancy naming. You are looking for clarity and discipline. You also want to know what counts as a version change, because some organizations only version major releases and ignore the smaller edits that can still shift behavior. A single label correction for a sensitive category, or a single filtering rule that removes a subgroup, can create meaningful differences even if the dataset is otherwise similar. You also want to see whether versions are immutable once released, meaning a version is locked and does not change, so you can always reproduce what the model saw. If people can edit a dataset version after the fact, then the version label becomes meaningless and auditability collapses. In everyday terms, a version should be like a sealed container with a label, not a jar that anyone can open and refill without recording it. Traceability is the next concept, and it means the organization can trace a line from model behavior back to the exact data sources, transformations, and versions that produce the training set. Traceability is often described as lineage, but the everyday idea is simpler. You can follow the breadcrumbs. If someone asks where a training record came from, you can identify the original source system or collection process. If someone asks how a raw record became a training example, you can show what cleaning, filtering, and labeling steps were applied. If someone asks what dataset version trained the model currently in production, you can point to a specific version and show the evidence. Traceability matters because it supports accountability when systems affect people. It also matters because it supports correction, since you cannot fix what you cannot locate. If an organization discovers that a certain data source contains sensitive information that should not have been used, traceability is what allows them to identify which dataset versions and which model versions are impacted. When you audit traceability, you are looking for an end-to-end story that is consistent, specific, and documented. A strong traceability story includes a data inventory that describes the sources, the purpose for using each source, and the rules that govern that source. It also includes transformation documentation that explains what was done to the data, not at the level of code, but at the level of intent and effect. For example, it should be clear whether certain records were excluded, whether certain fields were normalized, and whether certain categories were merged or split. Another important traceability element is the ability to reproduce the training set, meaning the organization can rerun the pipeline with the same inputs and arrive at the same dataset version. Reproducibility is a governance tool because it prevents debates from turning into opinions. If the organization can reproduce the dataset and show the lineage, it can answer questions with evidence rather than with memory. Controls are the third major concept, and controls are the practical rules and safeguards that prevent training data from becoming a free-for-all. Controls include access controls, so only approved roles can view or modify sensitive datasets. Controls include approval gates, so adding a new data source or changing a labeling rule requires review rather than being a casual decision. Controls include retention limits, so datasets do not accumulate sensitive information indefinitely. Controls include integrity protections, so datasets are not silently altered, corrupted, or tampered with. Controls also include monitoring and logging so the organization can see who accessed data and what they did, which matters for accountability and incident response. Beginners sometimes think controls are purely security measures, but in training data management, they also enforce ethical and privacy commitments. If a privacy program says certain data cannot be used for training, controls are what make that restriction real. If fairness concerns require review of representativeness, controls are what make that review routine. A useful way to audit controls is to focus on who can do what and under what conditions, who is allowed to add new records to a training dataset, and what review is required, who can change labels, and how are label changes verified for consistency and fairness, who can export training data, and is export limited to prevent uncontrolled copies, who can share data with external parties, and what restrictions exist for vendor reuse and retention. You also want to know whether there are separation of duties patterns, meaning the same person does not have unchecked power to select data, label it, train a model, and approve deployment. Separation of duties is not always necessary in small settings, but in high-impact use cases it is a valuable control because it reduces the chance of biased or risky decisions going unchallenged. The audit mindset is to treat training data as a controlled ingredient in a high-stakes recipe, not as a casual resource. Another important control area is quality control, because training data management is not only about preventing misuse, it is also about preventing silent failure. Quality controls include checks for missing data, unexpected value ranges, label consistency, and shifts in distribution over time. These checks are not advanced math. They can be simple comparisons and sampling that catch obvious issues early. A strong program also includes a method for handling data issues once found, such as correcting records, documenting changes, and creating a new dataset version rather than patching the old one. Quality controls should be tied to traceability so that when an issue is discovered, you can locate affected versions and understand the scope. For beginners, a key idea is that poor quality can create fairness and privacy problems as well as performance problems. If one group has systematically messy records, quality issues can become unequal outcomes. If free text fields leak sensitive information, quality issues can become privacy exposure. Good training data management treats quality as a risk control, not just a technical annoyance. Versioning, traceability, and controls come together most clearly when you consider incident response and investigations. Suppose a model starts producing harmful outputs, or a regulator asks the organization to explain how a model was trained. Without disciplined training data management, the organization may not be able to answer basic questions, which can escalate risk quickly. With discipline management, the organization can identify which dataset version trained the model, what sources were included, what transformations were applied, and who approved the changes. It can also identify when the dataset changed and whether the change correlates with a shift in behavior. This is the difference between being able to act with precision and being forced to make broad, disruptive guesses, like shutting down a feature because you cannot isolate the issue. In everyday terms, discipline management gives you a detailed receipt and a timeline, so you can pinpoint what needs to be fixed. Undisciplined management leaves you with vague memories and scattered files, which makes every decision slower and riskier. A particularly important traceability topic in training data management is linkage between dataset versions and model versions. When a model is updated, leaders should be able to see which dataset version it used, and when a dataset is updated, teams should be able to see which model versions depended on it. This linkage supports safe change control because it makes dependencies visible. If a dataset contains a newly discovered privacy issue, you can identify which model versions are affected and prioritize response. If a dataset change was intended to reduce bias, you can evaluate whether the model version trained on it actually reduced bias, rather than assuming the change helped. This is also where audit evidence becomes practical, because governance decisions should be recorded at the points where data versions and model versions connect. A beginner-friendly way to think about this is that the dataset is one chapter of the story and the model is another, and you need a table of contents that shows which chapter versions were used to create which model versions. Training data management also has to address the reality of multiple environments and multiple teams. Organizations often have development environments, testing environments, and production environments, and datasets can leak across these boundaries if controls are weak. A dataset used for experimentation might contain sensitive records that should never leave a controlled environment, but convenience can push teams to copy it into places it does not belong. Multiple teams can also create multiple copies of the same data, each with slight differences, which undermines versioning and traceability. A strong program defines where datasets can live, how they are promoted from one stage to another, and how unauthorized copies are prevented or detected. It also defines how vendors are involved, especially if labeling or training uses external services. Beginners can audit this by asking where copies exist, who can create new copies, and whether there is a single source of truth for approved dataset versions. If the answer is everyone has their own copy, governance risk rises sharply. Privacy and ethical constraints should be visible inside training data management, not only in separate privacy documents. If the organization has consent requirements, purpose limits, or retention rules, those should be enforced by the pipeline and recorded in dataset documentation. For example, if a dataset is allowed for training only in a certain context, that should be part of its metadata and its access controls. If certain sensitive fields must be removed, the transformation steps should document that removal and the dataset version should reflect it. If the organization promises to delete data after a period, retention policies should be implemented across all dataset copies, not only the primary one. A good audit question is whether the training data management system can prove compliance with these constraints, rather than relying on informal trust. Ethical AI is not maintained by good intentions alone. It is maintained by repeatable controls that are built into everyday workflows. One common beginner misunderstanding is to think that training data management is only relevant before the model is released. In reality, it matters more after release because that is when the model is used at scale and when drift and updates become necessary. When the world changes, the organization may need to retrain, and retraining is risky if the data pipeline is not controlled. Another misunderstanding is to think that versioning is only about saving old files, but versioning is also about making change measurable and accountable. A third misunderstanding is to treat traceability as a technical luxury when it is actually a governance necessity. In high-impact AI uses, the inability to explain data lineage can be as damaging as a technical failure because it undermines trust and can violate obligations. Training data management is the infrastructure that makes responsible improvement possible. Without it, the organization either freezes and cannot adapt safely, or it adapts blindly and increases risk with each change. To make this concrete, imagine an AI system that helps prioritize incoming requests for assistance in a public-facing program. At first, it is trained on historical requests and outcomes, but over time new request types appear, new policies are introduced, and a new channel is added. If training data management is weak, someone might merge new data without documenting the change, adjust labels to match new policy without versioning, and retrain a model that begins to deprioritize certain kinds of requests unfairly. If training data management is strong, the new data source would go through review, labeling changes would be documented and versioned, the dataset version would be traceable to the model update, and monitoring could compare outcomes before and after the change. If a complaint arises, the organization could investigate with evidence rather than with guessing. This example shows why versioning, traceability, and controls are not bureaucratic chores. They are the difference between controlled evolution and accidental harm. To close, auditing training data management in Domain 2A means looking for disciplined versioning, clear traceability, and real controls that shape behavior under pressure. Versioning should make dataset change visible, consistent, and reproducible, so the organization can compare past and present and roll back when needed. Traceability should provide an end-to-end story from raw sources through transformations and labeling to the exact dataset version used for training, so accountability is possible. Controls should enforce who can access, modify, export, and approve training data, while also supporting quality, privacy, and fairness obligations. When these elements are present, an organization can explain its AI systems, improve them safely, and respond to issues with precision. When they are missing, the organization can still build models, but it will struggle to govern them, and governance is what keeps AI from becoming a source of surprise harm. Training data management is the quiet foundation that makes responsible AI possible at scale.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.